Hello everybody, welcome to my simulation of natural selection. What you're seeing here is basically a very simple environment in 2 dimensions, which consists only of creatures, which are these triangles, and also food, which are these red and green pellets. So if we zoom out and take a look, you can see that there are quite a lot of creatures in this simulation currently. And this is a simulation which I've had running for maybe an hour, 2 hours, I'm not quite sure. But yeah, I'll just explain a bit about what's going on. Each of these creatures simply moves around. They have certain programmed behaviors, which is A, to target food, and B, to target a mate. They have energy, which is lost by movement, based on other factors as well, such as their size, their speed, their ability to see, whether they're gestating, they're mating, or what have you. And the only way for the creatures to die is by running out of energy, and the only way for the creatures to gain more energy is by eating food. So, these creatures also have about a dozen or so genes or traits which they can evolve over time. And some examples of the traits they have are, for example, their speed, their size, their view radius, their view angle. There is the percentage of energy which they pass on to a female when they mate, or for females it's the percentage of energy which they pass on to their offspring during gestation. There's also the gestation duration, which sounds kind of funny. That's just the length of time that a female will gestate before giving birth to a new creature. And yeah, a bunch of other things. If you want a more detailed look into this, all the source code is available publicly on my GitHub, and there'll be a link in the description. But yeah, let's have a look further at what's going on. So you might have noticed there's 3 different colours of triangle. The white triangles are just the male creatures, the pink triangles are the female creatures, and let's see, yeah, we just saw a purple one a second ago, it stopped being purple, but as you might have guessed, a purple creature is a creature that is gestating. Here's another one, so there we go, it just gave birth to another creature, which is larger than itself, but, you know, quite a lot. It probably had quite a large father. So yeah, the other thing about this program is that it outputs all the data. So if we go into Excel, where I've loaded it all in as a CSV, you can see some more of the traits along the top that are being recorded. So yeah, as well as the generation and the time since the beginning. So yeah, there are a couple of traits I didn't talk about before. Such as the boost likelihood, which is broken actually, so I'm not going to mention that one. But yeah, so because it's a CSV, we just put it into Excel, we can get really interesting graphs out of this. So this is actually for the population I have running currently. And yeah, you can see some interesting things about it, like here's the population count over time, with the number of individuals plotted. And you can see that it actually forms these kind of waves, which actually exists in nature. And I'll put a graph on the screen of, if I can be bothered. But this basically represents periods of growth and decline when the creatures start to get really well adapted to their environment, so they start growing exponentially. Then they eat too much food. The environment can no longer sustain the population, so they lose a large proportion of the population. Then they start to adapt to the environment again, and increases and increases. You get the idea. So yeah, that is incredibly fascinating. And if we move across, if we move across here, we've got the vision over time, which just shows the view radius and the view angle. So it looks kind of as though the vision isn't super important for the creatures. It is more worthwhile to just have the energy rather than to expend it on their vision, which makes sense if we look at the environment, because there's usually quite a lot going on. There's lots of other creatures. Food seems to be pretty scarce. However, because there's so many other creatures, it seems as though, this is just my speculation by the way, it seems as though maybe the creatures, it wasn't worthwhile being able to see, because even if they could see some food pellet really far away, it didn't matter because there were loads of creatures closer to it, so they still didn't get to it in time. So population size and speed over time, as you can see, the size, sorry, this is actually the wrong way around. The orange one should be the size, but I'll fix that after recording this. But yeah, you can see the size just plummeted pretty much straight away, and that's because there's actually I didn't implement any benefit to being large, so all the ones that were large were simply losing energy way too quickly because of their size and died, weren't able to reproduce. So yeah, the speed is going down at a much decreased rate, because in this environment speed is good because you can cover more ground and get more food at a greater rate, or find a mate before others. So over here we can see the male to female ratio over time. That's in blue. Yeah, that's in blue, the male to female ratio. So the closer the line is to the top, the higher proportion of males. And the reason I think that it tends towards males is because the females had a larger chance of dying during gestation, because it's a period of time when they are using up a lot more energy, because their energy has to go to their offspring. Their energy doesn't just get created out of nowhere. So I think that's why there tended to be more males than females at any given time. But as you can see here in the offspring ratio, which is the gene which determines the likelihood of an offspring being male or female, seems to actually be below the halfway point just about. So I have no idea as to why that is. If you might have any speculation, then it'd be cool to let me know. And down here below, the last one which I've graphed is the gestation length over time, and that is in seconds. So yeah, it looks like they found at some point 5 seconds, and that seemed to be pretty optimal, so it just didn't evolve any further. And because I've just imported this data from a CSV, we can actually refresh it and bring it back up to date, and we can see that there's been another few cycles of population growth and, I don't know, decay. Decay isn't really the right word, I don't think, but whatever. But yeah, that's my program. Oh, and it looks like the gestation period is going back up. It's gone up to 6 seconds, which is interesting. It would be interesting to follow that trend. But yeah, that is my simulation. I hope you found it interesting. Like I said, the source code will be in the description below, so you can build this and run it yourself. And yeah, thanks for watching. Just a couple more details which I forgot to add, which is how the traits actually evolve, and how the creature's mating works. So the traits can only evolve, can only change with a new offspring. When a male and a female creature mate, the female starts gestating, and at the point of the birth of the offspring, it gains the energy which was given to it by the mother and father, and as well as that, it inherits for each of the traits. It randomly decides between the trait in the mother and the trait in the father, and it does that for each of the traits. And then after that, it applies a small mutation to that trait. So, for example, this creature that was just gestating, when this one was born, it inherited either the size trait from its mother or the size trait from its father. As their sizes are pretty similar, I'd guess it probably inherited the trait from its mother, and then the mutation has caused it to become slightly bigger, but only a very slight amount. And the creatures will only target to mate when their energy is above a certain threshold, and the exact number of that threshold is actually a gene itself. So that's how that works. and just with this environment, with nothing else, and these rules, that is enough to promote evolution. And I plotted one more graph to show you, which is the mating threshold over time. So this is a percentage of their total possible amount of energy that they can have. So as you can see, that started, they needed half of their total energy before they could mate, and that has just slowly gone down, and it looks like this is pretty stable now. So yeah, that's all I wanted to add. Thank you very much. Hello, this is one final note, and that's earlier in the video I said that the orange was size and the blue was speed, and that they're swapped around. I was actually wrong. They actually are the correct way around, so the orange is speed. So yeah, this is quite a while later in the simulation, and you can see that the size is still steadily decreasing, as it is a useless trait to have. And you can see the creatures are a lot smaller than the last time you saw them, which is really cool to see. And the speed is actually starting to gradually increase as well, the food is more scarce because there's a higher population, I'm guessing. So the speedier creatures are getting more food and they're getting more mates. So yeah, I was just correcting that mostly.